There is an object in the universe so massive that if it replaced our sun, its outer edge would stretch past the orbit of Neptune. Every planet in our solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, would be inside it, and it would still have room. This is TON 618. It is a black hole, and it is not even close to the largest one we have found. Before we go further, understand what a black hole actually is. Not a hole, not an empty space. A black hole is an object so dense that its gravitational pull prevents anything, including light, from escaping. Once you cross the boundary called the event horizon, there is no coming back. Not for matter, not for energy, not for information. The boundary is invisible. There is no wall, no surface, just a point beyond which the laws of physics, as we understand them, stop working. And the largest black holes we have found are so enormous that the event horizon alone, just the boundary, not the object itself, spans billions of kilometers. Holm UCS. TON 618 sits 10.4 billion light years from Earth. It has a mass of 66 billion suns. Read that again. 66 billion suns compressed into a single object. Its event horizon, the point of no return, has a diameter of approximately 196 billion kilometers. That is 1,300 times the distance from Earth to the Sun. Our entire solar system, from the Sun to the outer edge of Pluto's orbit, is about 12 billion kilometers across. TON 618's event horizon is 16 times wider than our solar system. If you are falling toward it at the speed of light, it would take you nearly 8 days just to cross the event horizon. For a very long time, TON 618 was considered the largest black hole ever found. Then we found Phoenix A star. Phoenix A star is located at the center of the Phoenix galaxy cluster, approximately 5.8 billion light years from Earth. Its estimated mass is somewhere between 100 billion and 100 trillion solar masses. The uncertainty in that number is itself larger than TON 618's entire mass. To understand the scale of Phoenix A star, consider this. The Milky Way galaxy contains approximately 250 billion stars. The total mass of all those stars combined is a fraction of what Phoenix A star contains in a single object. Phoenix A star is so massive that astrophysicists are not entirely sure how to model it. The standard processes by which black holes grow, absorbing gas, merging with other black holes, do not fully account for an object of this size within the known age of the universe. Something fed it, something made it this large, and the leading theories are incomplete. Also, in the conversation is Holm 15. A star, the supermassive black hole at the center of the galaxy, Holm 15A, in the Able 85 galaxy cluster. Its mass is estimated at 40 billion solar masses, placing it among the 5 largest confirmed black holes in the observable universe. What makes Holm 15A star unusual is not just its size, but its environment. The core of the galaxy around it has been almost completely emptied, a vast, dim, nearly starless region surrounding the central monster. Astronomers believe this hollowing out is evidence of repeated galaxy mergers over billions of years, each one bringing more mass to the central black hole and scattering stars outward in the process. The galaxy was cannibalized from within, and the black hole at its center grew stronger with every meal. This brings us to the most important question in the study of ultramassive black holes. How The standard model of black hole formation begins with a massive star. A star many times more massive than our Sun reaches the end of its life, collapses under its own gravity, and forms a stellar mass black hole, typically between 5 and 100 solar masses. From there, black holes grow by absorbing surrounding matter and by merging with other black holes. This process, over billions of years, can produce the supermassive black holes found at the centers of most large galaxies, objects ranging from millions to billions of solar masses. But TON 618, but Phoenix a star, but Holm 15A+. These objects have masses that push against the limits of what standard accretion and merger models can produce in 13.8 billion years. Some researchers have proposed that the very first black holes formed in the earliest moments of the universe, before stars even existed, may have been far more massive than previously thought. These hypothetical primordial black holes could have seeded the growth of ultramassive objects far more efficiently than stellar collapse alone. Others have proposed direct collapse, where vast clouds of gas in the early universe bypass the star formation stage entirely and collapse directly into black holes of millions of solar masses from the beginning. Both theories are plausible, neither is proven. The honest answer is that we do not fully understand how the largest black holes in the universe came to exist. Now consider what it would be like to approach one. Contrary to popular image, you would not be immediately destroyed at the event horizon of an ultramassive black hole. The tidal forces, the difference in gravitational pull between your head and your feet, would actually be relatively gentle at the event horizon of an object as large as TON 618. The event horizon is so large that the curvature of space-time there is gradual. You would cross the boundary without feeling it, but from that moment, your future would contain only one destination, the singularity at the center. Time itself, inside the event horizon, is redirected. The singularity is not in a location in space, it is in your future. Every path forward leads there. There is no direction you can travel, no force you can apply that changes that destination. You would reach it in a finite amount of your own time. What happens at the singularity is where physics stops. Our equations produce infinities. Our models break down. Whatever exists at the center of a black hole is beyond our current ability to describe. The largest black holes in the universe are also, in a sense, among the oldest structures we will ever observe. TON 618 is so far away that the light reaching us today left it 10.4 billion years ago, when the universe was only about 3 billion years old. We are not seeing TON 618 as it is now. We are seeing it as it was in the deep past, in the early universe, when it was already 66 billion solar masses and still growing. What it has become in the 10 billion years since, we cannot know. The light carrying that information has not reached us yet. Somewhere out there, at a distance so vast the number loses meaning, the largest known object in the observable universe is doing something, and we are watching its ancient past across 10 billion years of empty space, with no ability to ask what happened next. If you want to know what happens when something gets too close to one of these monsters, subscribe, because the next video goes inside